Okay, I'm gonna be going through the two labs, okay, 2022 question 1 as well as 2018 question 1. Okay, so for 2022 one, this is the one, okay, where you have the copper 2 sulfate, the hydrated copper 2 sulfate. Okay, so what we are doing, we are actually decomposing it, okay, to form anhydrous copper 2 sulfate as well as water. Okay, so we are trying to solve for this X, the water of crystallization, okay, of copper 2 sulfate. Okay, in this particular lab notice, they already tell you that A is copper 2 sulfate. Okay, not every practical, okay, will you see them identify the unknowns for you. Okay, sometimes they'll just tell you A, B, C, so just take note of this. Okay, in this experiment, what you're required to do, just follow all the instructions very carefully. The one that you have to take note of, okay, is all the ones where you have to measure and record the mass. Okay, so notice here in step 2, they said measure and record the total mass. So this will be one mass you have to record, as well as part 1 where they say measure the mass of the boiling tube. Okay, all this time, whenever they mention all this, you have to take note, because later on you have to probably record down. Okay, in this case, yes, you have to do that. Okay, so you have to label it carefully as well. So first, in part 1 is in step 1 is empty boiling tube, in step 2 is total mass of boiling tube and solid A. Okay, take note, they say all the solid A. So some of you were asking how much to pour. Follow whatever the instructions tell you. Okay, next, take note, they say gently heat for approximately 2 minutes. This is very important. Okay, sometimes you will not know what the substance is, and that it's very hard for you to really know when to stop heating, so you just follow the instructions carefully. Okay, take note of a gentle heating. You don't heat it directly over the Bunsen burner. Okay, when you turn on the Bunsen burner, you want to probably turn off at half, okay, half open, okay, in terms of the tap for Bunsen burner. Okay, as well as always bring it above, and then wave your test tube over the Bunsen burner. Okay, don't directly heat it, because you might end up thermally decomposing the substance. Okay, in this case, you already know that is copper 2 hydrated copper 2 sulfate. If you end up decomposing this, right, your copper 2 sulfate will further decompose to form copper 2 oxide. Okay, and that is not, you do not want copper 2 oxide. So this copper 2 oxide is black. Okay, if you recall what we learned, anhydrous copper 2 sulfate is white, your hydrated copper 2 sulfate will be blue. Okay, so if you are given such information, please do a prediction before you even start the lab. Okay, so that you know what to expect. And the moment, if let's say I get black, I know that I need to redo my experiment. Okay, here they say it's important that A is heated gently in order to achieve accurate results. So if you do not heat gently, that's where you get the black color copper 2 oxide, and you need to redo. Okay, record your observations in A part 1. Okay, so this is here, the heating. Take note, your blue solid, remember it is a solid being heated. You should observe the solid either turn white or pale gray, or there's still some blue, depending on how much water crystallization is removed. Okay, you should also mention this, important. You should have seen colorless drops of liquid forming along the sides of the boiling tube, and that would be your water of crystallization being formed. Okay, so apart from looking at solid, please be more sensitive and observant to see whether any liquid forming. Okay, if there's colorless liquid forming, it is probably water, and you have to record that down. Okay, for the results, okay, we already talked about mass of empty boiling tube, okay, as well as A plus boiling tube. Okay, take note, some past years, some practicals, they do expect a table form. So to be safe, okay, you would want to just write all of this in a table form. Okay, and if you have a table form, please include the units, okay, after the heading. And do not, you can just ignore the units, okay. Do not write the units next to the numbers. So this is how you should present it. Okay, so ignore what is written here. Okay, make sure the units are written right after the labeling, okay, and then the numbers, take note, because the electronic balance gives you to 2 dp, you copy 2 dp as well. Okay, there's no need to find mass of solid A here, the 2.28 grams, unless you want to. Okay, there's an alternative way to solve for the x later. You can use this method. Okay, however, since it's not requested, you can choose not to calculate it. Okay, and you continue on. Okay, so they say after labeling your observations, leave the boiling tube to cool to room temperature. Okay, so follow what they say. They say you may start working on 1C while waiting for the boiling tube to cool. Okay, so please follow instructions, okay, because they have done this practical before they even assign it as the O-level question. Okay, so after you have done 1C, you come back, okay, step 6, reweigh the boiling tube and record the mass. Okay, so this is where, okay, you reweigh, okay, but they did not ask you to record the mass. Okay, so now you gently heat again for 1 minute. Okay, so leave the boiling, after you heat it gently for 1 minute, leave it cool to room temperature. Then you reweigh its contents. Okay, so sorry, after you heat for the 2 minutes, you have to weigh it first. So this is where the weighing comes in after 2 minutes. Okay, and this is after the 2 minutes of heating and cooling. And then after this 2 minutes, you go and gently heat again for 1 minute. So you just follow the instructions very carefully. Okay, once you have done the 1 minute cooling, 1 minute heating, you go and leave to cool to room temperature again. Then you reweigh again. Okay, so you should have mass of boiling tube and contents after 2 minutes, and then mass of boiling tubes and contents after 1 minute. So take note, this 1 minute happens after the 2 minutes of heating, followed by cooling. Okay, so you get 2 different masses. So in total, you should count. You should have 4 masses. Every time they say record the mass, you should have 1 mass recorded. So you have 1 in question 1, 1 in part 1, 1 in part 2, okay, 1 in 6, and 1 in 9. So in total, you should have 4 masses. So here I have 30.46 for the original empty mass of boiling tube, 32.74 for mass of A plus boiling tube, 32.08 for mass of boiling tube and contents after 2 minutes of heating, and 31.90 for mass of boiling tube and contents after 1 minute of heating. Okay, so when we mark your papers, okay, the markers will have their own range of values, and your values of the masses you record, right, have to be within a certain range of their own answer. So obviously we don't have their answer, we only have ours. Okay, so you just need to ensure that your answers should make sense. Okay, what do I mean by that? For example, if your mass of the empty boiling tube is 30.46, your mass of A plus boiling tube cannot be less than that. Okay, and after heating, you should already expect that this value, 30.08, it should be lower than this value of 32.74 because you are removing water of crystallization. So your mass cannot be higher than before. It should drop further. And after the final heating of 1 minute, it should drop even further again because you're removing more water. So these are some tricks that you can use to test yourself to ensure that you're on the right track. Okay, because honestly, it's quite difficult for you during the lab to really know whether or not you're doing the steps correctly. Okay? Okay, so next portion, now you have to calculate. Okay, so part 3, they ask you solid remaining after the second heating is this. They already tell you it's copper 2 sulfate. Calculate the mass in gram of copper 2 sulfate remaining after the second heating. A lot of you, I think you didn't read this value. So after the second heating means what? You have to take the final mass that you have. Okay, so in this case, I have 31.90. I need to subtract away the original mass of the empty boiling tube because I want to find the mass of copper sulfate, copper 2 sulfate remaining. Okay, what happened to the water? Notice, right, when you perform the thermal decomposition, water actually escapes. Okay, water of crystallization escapes as a gas. This one escapes. So this mass is no longer counted. So your mass will always be lower. Okay, so in this case, I take 31.90 minus 30.46, I get 1.44. Okay, as long as you take these two values and you subtract them accordingly, you should get this 1 mark. Okay, there will be error carry forward even for practical. Okay, next portion, part 4. Calculate mole amount in mole of anhydrous copper 2 sulfate. So it's just taking your value in part 3 divided by the molar mass of copper 2 sulfate. Okay, you should get around 0.009 mole provided your mass is close to 1.44. Okay, because the molar mass is always the same. So in this case, you have to know your mole formula. So which is why when you go for your practical, right, you need to already know some of your content. You don't need to know everything very well, but some things in particular, like your mole calculation and your QA, is better for you to know the content rather than rely heavily on the data sheet that you are given. Okay, because while you may have, for example, for QA, you are given the data sheet. If you don't really know what the information means, right, you might not be able to answer all the questions anyway. Okay, so in this case, let's proceed with part 5. They want total mass loss in gram, water loss for original sample of A after second heating. So same thing, after the second heating. So what do you need to do? Okay, you take, okay, they want the water loss, so I will take this value, okay, the solid A and the boiling tube, okay, subtract away your final mass again. So I'll take this value minus this value, okay, because I want to find the mass of water loss. So in this case, I'll get 0.840 grams, okay. Part 6 is just finding more of water, same thing. I take my mass from the previous part, divide by molar mass of 18. I should get like 0.0467, around there. Okay? And now finally, they say use the equation for decomposition and your answers in part 4 and 5. Okay, so I want this part 4 and 6. Use these two answers to calculate the value of x. Give your answer to the nearest whole number. Okay? Remember, water of crystallization is always a whole number. And it should, okay, you should expect it to be around the numbers you have seen for your water of crystallization, like 5 or 7. Okay? For this question, there's 2 ways to do. If you follow the one that they said using your answers in part 4 and part 6, you should get it in one step. All you have to do is you compare mole ratio of copper 2 sulfate to water. And you know the mole ratio from the decomposition equation is 1:x. And you know the mole of copper 2 sulfate is 0.009 mole and your mole of water is 0.0467. So if I compare mole ratio, okay, I know that to take x, I must take this, okay, because I'm dividing both sides, okay, by 0.009 to solve for x. Okay, which is why to find x, I'll take 0.0467 divided by 0.009 and I should get 5.18 and I round off to 5 as the whole number. So the answer should be 5. Okay, but don't worry if you didn't get 5, as long as your answers, your workings are correct, they will still give you error carry forward. Okay, there is another way to solve it, but it's a much longer way, which is using your original hydrated copper 2 sulfate, okay, mole ratio. So you have mole ratio 1:1 with your copper 2 sulfate. You should get 0.009 mole of hydrated copper 2 sulfate. Okay, then you can use the mole equation, right? You know the number of moles is 0.009. You know the mass is 2.28 because just now I actually found the mass by subtracting, right? I take this number minus this number to get the mass of solid A. And I know that my molar mass is copper 2 sulfate plus water. Okay, and because there's x number of H2O, it becomes 18x. Okay, then I equate 0.009 equals to 2.28 over 160 plus 18x, and I solve for x. Okay, I should get the same number, but it's taking, this method is very, very long. Okay, you might not have time to do this method during the exam, so you just follow whatever they tell you. Okay. So next part for 2022, okay, part B, part 1, they ask why is the sample of A heated twice in A? Okay, in your answer, you must state and explain whether heating for a third time will give a more accurate value of X. Okay, so firstly is okay, you have to state whether it's more. So yes, it will be more accurate, okay, and you have to explain, okay, why is it more accurate? Because remember, the goal is here, you want to ensure all water of crystallization has been removed. Okay, the only way you can get a completely accurate value of x is you need to ensure this part. Okay, so you have to just answer the question, yes, it will be more accurate as it ensures all water of crystallization is removed. Okay, you can ignore this part. Okay, for B part 2, they say another student carried out the experiment in A. Student heated the sample of A, strongly causing it to decompose to give a black solid and a pungent gas. When you see this pungent gas, you have to think of NH3SO2, okay, as well as your chlorine. So in this case, you look at the formula. Your original formula of anhydrous copper 2 sulfate, okay, is CuSO4.HX2O. The only possible gas here is SO2 coming from the sulfate. Okay, and you know the black solid here should give you copper 2 oxide. In fact, it is. Okay, it's not given, but you can make this prediction. Okay, so now they ask you state and explain the effect, if any, on the student's calculated value of x. So what happens now? If let's say I decompose my copper 2 sulfate, okay, which I form copper 2 sulfate first with your water, and this copper 2 sulfate, okay, further undergoes decomposition to form copper 2 oxide and, okay, and SO2. Okay, so the full balance equation should be this. Okay, if I have to balance it, okay, okay, this will be the full balance equation. Okay, so what happens now if I produce this instead? Okay, how will my x change? So the x, remember the x is here, right? But because now I'm causing more of these to decrease, okay, my copper 2 sulfate and hydrous 2 copper 2 sulfate is actually decreasing because I'm further, okay, when I weigh the mass later, okay, it's actually now copper 2 oxide, and some of the copper 2 sulfate has formed sulfur dioxide as well as oxygen. We have escaped. Okay, this one has escaped, which will cause this mass to drop as well. Okay, so because of this mass dropping, it will drop this mass. So now when I calculate my mass of copper 2 sulfate, okay, the mass will drop. So this mass will drop. This mass will drop. When this mass drops, I will get, okay, less moles as well. Because I'm taking the smaller value divided by same value, my number of moles will drop. Okay, because my number of moles will drop, okay, my 0.09 mole, this one will drop. Okay, so when the denominator drop, I divide by a smaller denominator, my overall value will increase. So in this case, your value of x will be larger due to larger mass loss, which includes mass of pungent gas. Okay, if you feel uncertain, there's no need, okay, do not need to identify SO2. You can just play safe and just say pungent gas. But the fact is, you know that there's a gas that escaped, so definitely your mass will decrease. Okay, so I'm going to move on to the next portion. Okay, now part C. Part C is quite straightforward. The explanation part, it will make more sense to you when we cover energy changes chapter. Okay, so now they just tell you anhydrous salts dissolve in water. Sometimes there's a temperature change as the salt dissolve. In this experiment, you will determine change in temperatures when dissolve anhydrous CuSO4 in water. Okay, so they tell you B is anhydrous copper 2 sulfate CuSO4. You will place a polystyrene cup into a glass beaker. Using measuring cylinder, measure 20 cm3 of DI water. Measure and record temperature of the DI water. Okay, so please make sure you follow the instructions carefully. You need to record this down. So record it here. Remember, okay, because it's using a measuring cylinder, it is, okay, nearest 0.5 degrees Celsius and it has to be 1 dP. So the last number should either be 0.5 or 0.0. Okay, next they tell you transfer all of B, so take note all, into the cup and use thermometer to stir until temperature no longer changes. Okay, then measure and record the maximum temperature. So as you transfer this, please take note, you have to be alert and look at your thermometer. Okay, so in this case, when we did it, our original temperature was 28.5, maximum we observed was 34.5, change in temperature 6.0. Okay, so just follow the DP, so 1 DP as well for the change in temperature. Okay, explanation wise, okay, you can just copy this answer first, it'll make more sense later. So because your change in temperature is positive, okay, your enthalpy H is negative. Okay, because of temperature increase, therefore heat is released and the reaction is an exothermic reaction. Okay, it will make more sense when we cover it later. Okay, so question 2 already covered. Okay, I just want to talk a bit about the graph question. Okay, so in question 2E, you are given all this data. Okay, you just need to plot a graph, okay, on the next page. Okay, so you can try to go and watch this link, okay, on the reaction, okay, on how to draw the graph. Okay, just take note that when you observe such a graph, right, because it's a rate of reaction graph, which we will talk about in the rates of reaction chapter, it will be a curve. Okay, so just take note, when you're plotting the graph, you have to plot the points correctly because they are all already given to you. Please make sure you plot correctly. For 16, there's no data, so please do not plot. Okay, so you'll just plot, okay, do a best fit curve. In this case, it's very obvious it's a curve and it's not a straight line. Okay, make sure you label your axes with the units and the headings. Okay, so from the graph, determine and the expected concentration of potassium manganate at 16 minutes. So you just read off, okay, 16 minutes, you read from the x-axis. You make sure that, because the question says from your graph, you draw, okay, you either indicate using pencil line, okay. So you just read up from 16, straight line, use your ruler, okay, then you read off to the left, make sure you dot the line so that the marker can see, okay, and you read off the value, you should get around 2.20 to 2.40 times 10 to the power minus 4 mole per dm cube. Okay, since they have already given you in this kind of standard form, you just follow. Okay, next, describe how the rate of reaction changes during the experiment. Use your graph to explain the answer. Okay, so if you look at the graph, you have to first look at T0 to 14. So can you see T0 to 14 is about here? Okay, the rate of reaction actually increases as the gradient of the curve becomes steeper. So can you see from gentle curve it becomes much steeper? Okay, and what's the reason? Because the products are being formed. Okay, so okay, then the rate of reaction slows down from T14. Okay, so the moment after T14, this portion, you notice that it becomes more gentle again. Okay, why? Okay, the gradient becomes gentler as the reactants get used up. Okay, so this expression will cover more in the rate of reaction chapter. Okay, so for now, just focus on plotting this graph with this shape. Okay, now for 2018, I'm only going to focus on 1A and 1B, okay, because you won't be able to answer the questions yet. Okay, take note, for your recording of your temperature, same thing. Okay, highest temperature, you need to be very sensitive and observant. The moment it hits the highest temperature, you need to record down your temperature. If you miss it a little bit because you are busy or you're not paying attention, okay, it will actually affect your change in temperature value. And because this kind of reactions, actually they go quite quickly, your temperature change might be this highest temperature might only last for a few seconds. So you need to be ready at all times, okay. Basically, how do you capture this? The moment you start the reaction, eyes on the thermometer at all times. Okay, and just mentally take note of the highest temperature you observe. Okay, so in this case, these are the highest temperatures we obtain. It actually doesn't matter because we are only looking at the changes in temperature. So initial temperature, depending on whatever you recorded, take note of the same thing, 1 decimal place, okay, closest 0.5 degrees Celsius. Do not include units here because it's already given in the heading. Okay. Also take note, another thing in this question is, can you see that this total volume of P plus water is always 10? So take note of this. They always want to ensure that the total volume is 10 cm3. Okay, so how do we mark the table? First marking point is all table readings recordings to nearest 0.5 without units in the table, you get 1 mark. Okay, temperature changes accordingly calculated to 1 dP, which is all this. If you take highest minus initial, as long as you give us the correct values, you get another mark. Okay, if you get full set of data plus correct trend, which is, okay, as your P decrease, okay, P decrease, your temperature change should follow likewise decrease. So if you get this full set of data plus correct trend, okay, you will get another mark. And finally is the accuracy of your data. So if your temperature changes are within, okay, plus minus 1 degree Celsius of our supervisor reading, which is our reading. So if 3 of your values are within plus minus 1, okay, so for example, if you have 14, 13, 10, and these two are out, you will still get the 1 mark. Okay, so value of X really decided on the center's result, so which is based on our own results. Okay, so you don't have to worry too much as long as you follow the instructions carefully, you capture the maximum temperature as accurately as you can, your value should be within range of hours. Okay, so for part B, okay, the question, I believe they ask you about the observation made when zinc reacts with aqueous copper 2 sulfate. So this one we have already covered in reactivity series. Okay, because zinc is more reactive. Okay, zinc is more reactive than your copper. You would expect, okay, even before this reaction happens, okay, carrying out this reaction, you should expect zinc to displace copper from copper 2 sulfate. Okay, so your blue solution of copper 2 sulfate will turn colorless because zinc sulfate is colorless. So this is blue solution is copper 2 sulfate, colorless is zinc sulfate. So the reaction in this question is actually zinc plus copper 2 sulfate giving you zinc copper plus zinc sulfate. Okay, zinc sulfate is aqueous, copper is solid, zinc is solid, and copper 2 sulfate is aqueous. Okay. Okay. You should also talk about the deposit observed because your zinc is a solid. Okay. Usually we want the change because there's no really change in the change now is the deposit of copper. Okay, so even if you don't write the original color of zinc, we will still accept. You can just say brown pink or brown pink solid deposit observed, and that is copper. Okay, common mistake was turn black. Okay, so if you add excess zinc, right, okay, you might see black color. So take note of what you are adding also. Okay, other mistakes, black PPT, black solution, gray solid turns clear, turns transparent. Okay. Okay, the explanation wise, question D asks you for explanation, so you just have to say more reactive zinc displaces less reactive copper from its aqueous solution. Hence, blue copper 2 sulfate turns color into colorless zinc sulfate solution. Okay, so take note, if the question does not ask you to make reference to reactivity series, you cannot just mention that zinc is higher than copper in the reactive series. You must explain what it means. Okay, so you have to say because zinc is higher in the reactivity series, is more reactive than copper. Okay, so they do not accept exothermic reaction also because it's already in the experiment. Okay, so that's all for the 2022 as well as 2018 question 1.